In this video, we'll be reviewing the distance formula and how it connects to the Pythagorean theorem. So we're going to first look at what the Pythagorean theorem is and how we use it. So we're talking about a triangle ABC. If it is a right triangle with legs AB and hypotenuse C, then all of these things will be true. So if you want to see that visually, that is our diagram down here. So we have side A and side B and side C. A and B are the legs of our triangle. Legs are the shortest two sides of a right triangle, and they meet at a 90-degree angle. So A and B are the legs. C is always the longest side. It's the hypotenuse of our right triangle, and it is always directly across from the 90-degree angle. We use the Pythagorean theorem to find the missing sides of right triangles and to determine if a triangle is a right triangle. So the actual Pythagorean theorem is a squared plus b squared equals c squared. So that is side A, a leg, plus side, or squared, plus side b squared, the other leg, will equal the hypotenuse c squared. So you take your two legs and square them and add them together and set them equal to c squared and use that formula to help you find missing lengths in a triangle, specifically a right triangle. So we're going to apply that Pythagorean theorem to find the missing lengths and then also to determine whether triangles are right triangles or not. So in my first example, I have this triangle. We can identify that the legs are 3 and 6, and C is our missing side. So what I like to do is A would equal 3, B would equal 6, and C is unknown, so we don't know it. Now you could have said that A was 6 and B was 3. It doesn't matter as long as you're setting these two as your two legs. Algebraically, you're going to get the same thing. So we use the Pythagorean theorem and we plug in the values that we know. So A squared would be 3 squared, and B squared is 6 squared. We set this equal to C squared. 3 squared is 9, 6 squared is 36. We add them to get 45, which equals C squared. To figure out what C is, we need to undo a square, which is to take the square root. When we do that on both sides, the square root of 45 will equal C, because a square root and a square cancel each other out. Now this is our answer, but we can actually simplify this a little bit more. If you recall simplifying radicals, we take that square root of 45 and we ask ourselves, well, what are the factors of 45? And some factors of 45 that are helpful here are 9 and 5. We can break up these problems by saying the square root of 9 times the square root of 5 is the same thing as the square root of 45, and the square root of 9 is 3. So the actual simplified version of our answer here is 3 root 5 equals C, and that is our final answer and the length of what our side C would be. We'll repeat the process here, so if you'd like to pause and try it on your own, go ahead. A is going to be 2 root 3, B is root 5, and C is unknown. C is our hypotenuse because it's across from the 90-degree angle. These two shorter sides are meeting at that 90-degree angle, so they are our legs. So we can set them as A or B. It doesn't matter which is which. I'm going to use Pythagorean theorem and plug in my values to figure out what the hypotenuse length is. So A is 2 root 3, and I'm going to square this entire side. I'm going to add that to root 5 squared and set it equal to C squared. When we square a radical and a number outside, we're doing 2 root 3 times 2 root 3. So this is really like saying 2 times 2, which is 4, times square root of 3 times square root of 3. The square root of 3 would be root 9. Square root of 5 squared would be the square root of 25, which equals C squared. We have a little bit more algebra to simplify here. The square root of 9 is 3, and the square root of 25 is 5. We get 12 plus 5, so 17 equals C squared. To do our last step, we just have to take the square root of both sides to get C by itself. So C equals the square root of 17. Now there are no other factors of 17 besides 1 and 17, so we can't simplify this any further. So our final answer for the length of the hypotenuse here would be the square root of 17. In our last example, it's a little bit different because this time we don't know what a is. We're missing one of the legs. We know the other side is 5 for our other leg, and our c value is given to us this time as root 43. So we still use our Pythagorean theorem and fill in what we know, and then simplify. So we don't know a squared. We know 5 is b, so we'll square that, and then we'll set that equal to the square root of 43 squared. When we simplify this, we get a squared plus 25 equals the square root and the square are going to undo themselves, so we get 43 over here, 43. We subtract 25 from both sides, and we get a squared equals 18. So then from there, we're just going to take the square root of that, and we get a equals square root of 18. We can break this up, and we can say that this is the same as square root of 9 times the square root of 2. Square root of 9 is 3, and then we can leave the root 2. So the most simplified version of this would be 3 root 2, and that is our missing leg. Now that we've practiced using Pythagorean theorem to find a missing length, the other way we're going to use it is to kind of do it in reverse, and now that we're given 3 lengths, determine whether this does make a right triangle or not. So for it to make a right triangle, then the a squared plus b squared equals c squared must be true. So I'm going to take a pause on this first example and go through the second two with you before we try the last one. So in this middle example, we think that this should be a right angle, but we don't know for sure. Assuming that's our right angle, then this could be our A for one of our legs, and this could be B for one of our other legs. This would mean that 25 is C, our hypotenuse. We're going to set this into the Pythagorean theorem, so 10 squared plus 24 squared should equal 25 squared, because A squared plus B squared should equal C squared. 100 plus 576 should equal 625. That gets us 676 equals 625. Well, we know that this is not a true statement, so this would not be a right triangle because the Pythagorean theorem did not work. Here we've got 4 squared plus 6 squared should equal 8 squared. I know this because this looks like it should be the right angle, so the side across from it should be our hypotenuse, C. We also always know that our hypotenuse is the longest side of the triangle. So this could be A and this could be B. We're going to simplify this, so 16 plus 36 should equal 64. When we add these two numbers together, we get 52, and that does not equal 64. So again, we do not get a right triangle here because it did not work for Pythagorean theorem. Now in this one, they are not telling us which ones are the legs and which one is the hypotenuse. We always know that the hypotenuse is the longest side of the triangle. This 2 root 10 is a value that we can figure out, but we don't know it exactly right now, and that's going to help us decide which one of these should be our C value. So 2 root 10 would be the same as the square root of 4 times the square root of 10, because the square root of 4 is 2. When I multiply two radicals together, I can multiply the number underneath, so 4 times 10 is 40. So the square root of 40 would be about 6.3-ish, and I'm knowing that because the square root of 36 is 6. It's a little bit bigger than it, so I'm estimating it to be about 6.3. So if that's about 6.3, we know that that is one of our smallest sides on this triangle, which would tell us that 11 is our hypotenuse. So I'm going to say 9 is our A value, this will be our B value, and this 11 is our C value. Knowing that, we're going to use the Pythagorean theorem to decide whether or not this is a right triangle. So my A is 9, my B value is 2 root 10, and my C value is 11. 9 squared is 81. When we square this, we get 4 times root 100 equals 121. We do 81 plus 4 times 10. That's 40 plus 81 should equal 121. Those two numbers added together do equal each other. And so since these are true statements here, then this would make a right triangle. So we're using the three sides that are given here to plug it into the Pythagorean theorem still and see if we get a true statement. The only one that worked was actually this first one here. Remember that your hypotenuse always has to be the longest side, so that's why we decided at the beginning which one would be the longest before we plugged it in. So now we're going to explore why the distance formula is based on the Pythagorean theorem. So yesterday you learned that the distance formula is x2 minus x1 squared plus y2 minus y1 squared. And we're going to see why that works with the Pythagorean theorem. So the first thing I want you to do is use the distance formula to find the distance between A and B. Pause the video and try this by yourself. Point A was given to us at 6, 4. Point B was given to us at -3, -4. So when I plug into my distance formula, I get -3 minus 6 squared plus -4 minus 4 squared. Under the radical, I end up getting -9 squared plus -8 squared. This will be 81 plus 64 under the radical, which gets us a total of 145 under the radical. We then can use this to solve the Pythagorean, or using the Pythagorean theorem. So the other way to find the distance between A and B, aside from using the distance formula, is to draw a right triangle. So I drop a leg down from A and create point C, and that is where my leg from B to C meet. So C is right here. We can use this to figure out how long are these two legs and then plug into the Pythagorean theorem. So between A and C, I just have to count the length of this side. And if I count all the boxes, there are 8 there. So I'm going to say that my A value is 8. I can then count the distance between B and C, and that is 9 boxes. So B is going to be 9. We're going to figure out what our hypotenuse C is, which is going to be the same thing as the distance between A and B. So we don't know it yet, and we're going to use Pythagorean theorem to help us. So we do A squared plus B squared should equal C squared. Well, A is 84. We add that to B, which is going to be 9 squared, and we set that equal to C squared. We get 64 plus 81 to equal C squared, which becomes 145 equals C squared. We take the square root on both sides, and we end up getting that C equals the square root of 145. Again, that is exactly what we got when we took the distance formula and plugged in those 2 points. So that's just another way that we can find the distance between them, is to just create this right triangle and then use the distance formula. We can see that these are very similar, because if I wanted to find C, I would use C equals the square root of A squared plus B squared. And I got that from my original Pythagorean theorem of C squared equals A squared plus B squared. To just get C, I have to take the square root of both sides, and I'm adding the length of A and B squared, which is that distance between A and B. So we're using those points and plugging them in here to create that. So that's how our distance formula and our Pythagorean theorem are related. So I want you to try these 2 problems on your own. Use the distance, or don't use the distance formula, use the Pythagorean theorem to figure out how far apart these 2 points would be. Go ahead and pause the video and come back when you're ready to hear. So I'm going to drop a leg from this red point and then also create a leg from the blue point. They're meeting at this right angle right here. This is kind of creating that triangle that I'm looking for to use the Pythagorean theorem. This would be our C value. I'm going to call this A and this B. Counting the boxes, A will equal 4, B will equal 3, and I don't know what C is yet. A squared plus B squared should equal C squared, so 4 squared plus 3 squared equals C squared. We get 16 plus 9 equals C squared, so 25 equals C squared. When we take the square root on both sides, we end up getting c equals the square root of 25. That's one of our perfect squares though, so the length of c equals 5. We're going to do a similar process here, and I could draw my leg going to the right from the blue point and coming up from the green point. They meet at this 90-degree angle, creating our right triangle. This will be our hypotenuse, C. I'm going to label this as A and this is B. A is 2 units long. Oops, sorry, my pen's going crazy there. And B is 5 units long. We're going to use this to help us figure out what C is. So we use A squared plus B squared equals C squared. So 2 squared plus 5 squared will equal C squared. 4 plus 25. So we get 29 equals C squared. Take the square root of both sides, so C will equal the square root of 29. And that will be the length of our hypotenuse.